Christian here for Display Central. I'm in the Christie booth where I'm looking at their LED wall, which is a new product called Velvet. And this is actually a new product from Christie. And this is an LED wall that what they're showing here is a wall that's physically 6 foot by 24 foot. It's composed of 18 by 6 cabinets. And the resolution of this is 2880 by 720. And it's based on 2.5 millimeter pitch product. It's putting out about 1,000 nits. It's obviously very, very bright and very effective display. It's also slightly curved, so it has a more of an immersive feel when you look at it that way. Now, each module in each cabinet is actually 160 by 120 pixels. And this is the first of the product line that will be available in the September-October timeframe. So they're going to have a 2.5 millimeter, which is what's showing here. They'll have a 3 millimeter, a 4 millimeter, and they'll actually also have one smaller pitch at 1.875. So that's going to be very compelling. They're focusing on the indoor applications, casinos, retail malls, etc., places where you want to create some wow factor. We also had a chance to take a look in back of the display to see how this thing is run. And basically, the idea is to have a series of sources that could be from servers, it could be from a Blu-ray player. Those all go into some kind of a palette controller. In this case, they're using a spider to create that palette and to manage how the information is distributed across that palette. A single source then goes out over a Cat5 cable. And this is not an HD-based T cable. This is proprietary encoding. Goes out over the Cat5. These go to the controllers that will drive each of the modules. In this case, they have 3 controllers. That then gets delivered to each segment of the display, and then daisy-chained again using Cat5 cable all across the matrix. So fairly simple solution if you want to configure this. One thing they've also done that's a little bit different than other LED wall makers is in the design of the LED modules themselves. Most other LED makers include a black matrix that goes over the module that kind of fills in the space between the actual LED elements themselves. They do this because the LEDs are basically mounted on a printed circuit board, and that PCB may have some imperfections, so the black matrix kind of covers this up, gives it a nice uniform black look, which may, some will say it will enhance the contrast. Others will say that it can detract from the look of display at off angles, and especially when it's off. So what Christie has done is say we're not going to use that black matrix. We're going to actually apply a more uniform paint or finish to the PCB itself, so it has a better and more uniform look without that black matrix. The second thing they're also going to do, it's a little bit different, is they're going to have basically a uniform fill factor across their line. So typically an LED maker will select a 1 millimeter square LED or a 1.3 millimeter square LED, and they'll mount those same LEDs no matter what the pixel pitch is. So as the pixel pitch goes up, the fill factor goes down and down and down. So in other words, there's more space between the individual LED elements. What Christie will do is actually try and maintain that fill factor, which means they actually have to increase the size of the LED as that pixel pitch goes up. Typically, they'll try and have a fill factor that will be in the range of about 30% across that line. That also has the side benefit of being able to produce higher brightness displays and more efficient displays using those bigger LEDs. So I think that's pretty much the story from Christie here on the LED side. Christian for Display Central.